Hi mathematicians, here's another problem I'd like to go through with you. Determine the stationary values of these functions and analyse their nature. Here's the first one, y is equal to x minus 4 over x squared. First, we can rewrite this to be x minus 4x to the minus 2. So dy dx is equal to 1 add 8x to the minus 3. A second derivative, d2y over dx squared is equal to minus 24x to the minus 4. Well, we know that at turning points, dy dx is equal to 0. We do know dy dx is also 1 add x minus 8x to the minus 3, and so we can equate this to 0, which we can rearrange again to give 8 add, let's write this a little higher. We know that 1 add 8x to the minus 3 is equal to 0, which is the same as writing 8 add x cubed over x cubed is equal to 0. And this gives us x cubed is equal to minus 8, so we have x is equal to negative 2. So now we've found our first x coordinate, which is, and our only coordinate, which is negative 2 x coordinate. We can look at the sign of the second derivative, which is d2y over dx squared, which is minus 24x to the minus 4. So we have d2y over dx squared is equal to minus 24 to minus 4, which is equal to minus 24 minus 2 to the minus 4. And this is negative, it's less than 0. And this gives us a maximum this is a maximum turning point. Now we can go ahead and find our stationary value by substituting negative 2 into the equation of the curve, which is y is equal to negative 2 minus 4 over minus 2 all squared, and this is equal to negative 3. So we have a maximum turning point, and negative 3 is the stationary value at that turning point. Thanks for watching this video. I'll see you on the next problem.